try to find my
Hello and welcome back. In this relatively quick lesson, we're going to create an SSH key pair to use for any of the EC2 instances that we create. There's not going to be any terraform in this lesson, just some relatively basic Linux commands. If these commands are foreign to you, I'll be sure to include some documentation to help you understand what's going on, as this is a very important and fundamental skill required for any DevOps position. So, let's get started. Alright, so here I am in my terminal once again, and we've just got a few commands to run, and not much else to do here. So first up, let's run ssh keygen-t RSA. Now, as you see, I'm using an RSA cipher. Now, if you take a look here, the reason we're going to use RSA instead of something a little more production-ready like ED25519, which is a good bit more secure, is that this type of key does not support Windows.
Keys are not supported by Windows. Is it oh, okay. Not there. Cuma buat
Instances, EC2 Instance Connect, or EC2 Serial Console. Now, although we're not going to use those, I just want to make sure that you understand why you might choose RSA over ED25519, and that's what we're going to choose. So go ahead and hit enter there, and now we need to save this to a file. So make sure here you use the full path name, home ubuntu.ssh/, and I'm just going to call mine mtc key, just like so.
Kayaknya gue udah ada tutorial gitu. SSH. Ganti namanya ya. Home Mikey Mikey.
So, you can name yours whatever you want, just make sure you remember what you named it. And then as far as passphrase goes, we're not going to use a passphrase. Let's go ahead and skip that. Alright, so everything is good to go there. And if I run an ls home.ssh, I can see I have mtc key and my public key here in this directory. So that's where I'll go if I need to use these later. Alright, so now we've created the key. One more thing I wanted to mention is this is actually possible within Terraform, but there is a very good reason why we didn't do that also. So you can create a TLS private key within Terraform that you could potentially use to log into instances and whatnot, but the private key generated is unencrypted in your Terraform state.
The private key by this resource will be stored in unencrypted in your Terraform file for production deployment application
file. And that's something we just kind of want to avoid wherever we can. Now, if you're trying to deploy an ephemeral instance or something that honestly is going to be very short-lived, this might be a really great way to knock that out very easily. But again, once security is a concern, this is probably not the route you want to go, even though the state file is kept securely within Terraform's cloud. Alright, so that's really all we have for this lesson. Come on back to the next one and let's continue the course. Hello and welcome back. Before we continue with our infrastructure, we're just going to do a little spring cleaning and organize this project just a tiny bit to make it a little easier to manage. So first of all, what I'm going to do is delete this Terraform Cloud key. Not a big fan of having that just sitting around. I know that it is stored in plain text on this terminal, but we might as well not have it stored in plain text within our home folder. So I'll go ahead and delete that. Again, can always just create a new key if it's needed. Now the next thing I'm going to do, just to make things a little easier, is I'm going to delete this dev.tf. Vars right now, we may add another one later, but right now we don't need it, so I'm just going to get rid of that. And then our terraform.tf state, obviously not using that anymore because it's all in the cloud. So I'm going to delete these two files here. Delete just like so. And then the next thing I'm going to do is create a compute.tf file, and I'm going to rename main.tf to networking.tf.
Oh. cloud. Apa ya passwordnya kemarin? I'm a walrus. Aduh, salah lagi. Aduh, lupa terus. Aduh, lupa. Oh, ini bisa. Apa passwordnya? Iya betul terus.
Just like so. So we're going to have these split up a little bit. They'll still be run. These aren't run as separate modules or anything like that. It's still considered one large deployment, but it's going to be easier for us to manage. Since we were starting to get up there in number of lines here, we really don't want to start adding a bunch of EC2 resources and all the other resources to the bottom. I would much rather just have those split off into a different file. So we're going to start on our next lesson by creating our compute resources right here within compute.tf. Alright, so that's about all we've got to do here. Go ahead and mark this lesson complete. Come on back to the next one and we will continue the course. Hello and welcome back. In this lesson, we're going to start building our EC2 instance. But to do this, we'll obviously need to choose an AMI from which to deploy that EC2 instance. And to do that, we'll use the AWS AMI data source. So, let's get started. Just like the AWS Availability Zones data source, the AWS AMI data source will query the AWS API and provide a list of all of the AMIs that match our criteria. As you can see here, we've got all sorts of different attributes on which we can filter and query, and we'll be using a few of these, not all of them, but a few. So let's head over to the EC2 console and take a look to find exactly what we're looking for. I'm just going to click on Launch Instance. We're not going to go through this whole process, just like so. And what I'm going to want is the Ubuntu Server 20.04 LTS right here. Now, as you can see, we've got an AMI ID. And as you can see, I am in the Northern California region. If you're in a different region, you'll want to take note of that, as your AMI will be different. I'm going to head back to my console here, and let's just kind of take a look at what this AWS AMI data source is going to query. So if I run AWS EC2 describe images, image IDs, paste in that AMI, region US West 1, just like so, we can see we've got a lot of information here. And of course, most of this was on our page here, but this is a little more streamlined for us. So what we're going to want is we're going to want this owner ID, and then for filter, we're just going to want the majority of this image.
Oops. Iya benar.
image location, not the whole thing. As you can see, I am in the Northern California region. If you're in a different region, you'll want to take note of that, as your AMI will be different. I'm going to head back to my find exactly what we're looking for. I'm just going to click on Launch Instance. We're not going to go through this whole process, just like so. And what I'm going to want is the Ubuntu Server 20.04.
Ini bagian tuh apa nih? AMI ID-nya.
Or LTS right here. Now, as you can see, we've got an AMI ID.
Oh, iya.
And as you can see,
AMI ID, oke. Kamu paksa aku
in the Northern California region. If you're in a different region, you'll want to take note of that, as your AMI will be different. I'm going to head back to my console here. And let's just kind of take a look at what this AWS AMI data source is going to query. So if I run AWS EC2 describe images, image IDs, paste in that AMI, region US West 1, just like
bentar dulu deh. Kita setup dulu AWS. How to AWS configure. Get. Belum tahu. Apa yang mati? Loh. Dan ke Sumak. Juga di sini. How to uninstall LibreOffice. default region name-nya wih, udah bisa. GG Gaming. Ini ya nih, sama pakai ini nih.
So, we can see we've got a lot of information here, and of course most of this was on our page here, but this is a little more streamlined for us. So what we're going to want is we're going to want this owner ID, and then
Owner ID.
and for filter, we're just going to want the majority of this image location. Not the whole thing, but the majority of it. And the reason is we want to make sure that we get the most recent image. Now this here means that we're only getting that version, but we want to continue to get the most updated version since we're not doing anything that we expect to be breaking anytime soon. Of course, if your company's goals conflict with that, you may want to freeze it to this very specific AMI version. So let's just go ahead and start typing this out. So I'll type data, AWS AMI, and I'll just call it server AMI, just like so. And then, as you remember, we have a few options here. The one we're going to use right now, most recent equals true, and then we'll be using owners as well. Keep in mind that you can specify self, but we won't be doing that. So what we're going to do here, we just specify that most recent equals true, owners equals, and now again, that is plural, so it's going to show up in brackets. Let's grab our owner ID right here. And that owner, I believe, is canonical. And then finally, we want to do a little filtering. So we'll do a filter. Name equals name, just like so, because we want the name of the image, which, as you can see, shows up right here. This is the name of the image, obviously very similar to the image location, but it doesn't have the owner in front of it, and since we've already specified the owner, we don't need it. So name equals name, and if you look here, you can see this filter, name equals name, and if you look at the values, you'll actually see you can use asterisks here. So let's go ahead and do that. What I'm going to do, just copy everything before that date there. Values equals, and once again, plural, so in brackets. Let's paste that in. I'll add a little dash here, end with an asterisk, and wrap the whole thing with quotes. Just like so. Okay, so this here should return the AMI that we're hoping for. Let's go ahead and run a terraform apply, auto approve. Now I've already applied before this. If you
forget Ubuntu images akhirnya Ubuntu and people. Kita baru.
you have destroyed, of course you'll be deploying a lot more than I will, but I shouldn't have anything that has changed, so I shouldn't have to deploy any new resources. No changes, just like so. Perfect. So now if I do a terraform state show data.awsami.server,
Terraform apply. Udah lama juga. Rating ya. Gua matiin. Terraform state show data.rsmi server ami dot server.
AMI. There we go. now have AMI.
Oke, ini EMI ini. EMI itu ibarat kayak ISO-nya lah.
There we go. We now have the AMI that we were looking for. Absolutely perfect. So now at this point, we are ready to start building our EC2 instance. So go ahead and mark this lesson complete. Come on back to the next one and let's continue the course.
Strawberry. Like
Hello and
summer
welcome back.
evening.
In this lesson, we're going to finally deploy an EC2 instance. This is going to be another one of those iterative processes as we have a lot of attributes to work with, but soon we'll have an AWS deployment that actually does something. Now keep in mind, we are deploying an EC2 instance and the Cloud9 instance you're using is also an EC2 instance. So that means your free tier will be burning down twice as fast. If you want to save the $5 or so that this would cost, I would recommend destroying this infrastructure after each study session to ensure you don't incur any extra costs. Alright, so now that that's out of the way, let's get started. So first let's take a look at the AWS instance docs here. As you can see, this should look somewhat familiar. We have our data source for our AWS AMI, and then all we have to do is add the AWS instance resource to that. Now, as you can see, there is a lot that can go in here, and we're going to use nowhere near all of this, but we're going to use several of these attributes to build our EC2 instance. For instance, we'll be using tags, key name, VPC security group ID, subnet ID, root block device, and possibly a few others. So let's go ahead and start knocking this out. Now to start, we're going to keep it pretty simple. We're just going to start with resource, AWS instance, just like so, and then let's just call this MTC name. Open and close those braces there. Now we need to provide an instance type. Instance type, let's go ahead and allow ourselves to define that from a variable. So var.main instance type, just like so. And before I forget, I'm just going to jump into variables.tf. Variable, main instance type, type equals string, default equals t2.micro, just like so. Head back over to our compute.tf, and next we need to specify our
My main instance. Variable tadi main instance type.
AMI. So over to our compute.tpro, just like so. Head back over to our compute.tf, and next we need to specify our AMI. So that, as you might have guessed, is data.aws AMI.server AMI.id, just like so. Again, one of the output attributes of this AWS AMI is its ID, and you can actually see that used here in the docs, just like so. Data.aws AMI, they call this one Ubuntu.id, so you can always use this as a reference for that data source and resource together. Alright, so now that we've done that, let's go ahead and I'm just going to put a placeholder here for key name. We haven't quite got this set up yet. We're going to set this up in a variable, but for right now we're just going to leave it alone. So just comment that out, add a blank string there, just like so. Next, let's do VPC security group IDs, just like so. Now, as you remember, this is plural, which means that it's going to be a list in brackets. So we're going to use AWS security group.mtcsg.id. As you remember, if we head over to our networking, we can and check out our security group. It goes down near the bottom. There we go. AWS security group.mtcsg, just like so. And then again, Again, we're just specifying that ID, and because this is plural, it is in these brackets. Next up, we need a subnet ID, and that is not plural, so we only need one. So that is going to be AWS subnet.mtc public subnet. Now we would want to say .id, but remember, we have multiple subnets here. We have actually created multiple subnets, so if I scroll up, I can see our public subnet here. We've actually got a count, which means there's going to be multiple subnets, or if there's only one, it's still going to be counted, so it needs an index. So since we're not counting our instances yet, all we're going to do is just specify the first instance of our public subnet, so 0 here in our brackets. Now we're going to convert this to accept a count argument very soon, but for right now, we're just going to hard code it and keep it simple. Now after that, we're going to specify our root block device, just like so, volume size equals var.main vol size. We're going to specify this as a variable also. So let's head over here, variable main vol size, just like so, type equals number here, since we're going to be specifying a number, not a string. In default, we will just say 8, and this is in gigabytes. So if we head to the AWS instance docs here, I've actually already scrolled down for you. You can see volume size of the volume in gigabytes. So just keep that in mind, and then we'll head back over to our compute.tf, and let's add some tags. So tag tags equals name equals mtc main, just like so. All right, so now that's done. We've got our EC2 instance pretty much scaffolded out. Obviously, we have some
been declared in the root model. Ini apa nih? Gak ada. My private public table, apa namanya, our security group authority. Udah ada PSC. MySC. Udah ada di root. MySC. udah ada guys. iaac security group. Security. Copy. Aneh banget anjir. Tidak ada di sini. Oh, bisa jahat. Aku sabar evening. My SG udah ada. Tadi terraform apply udah ya. Oh tadi plan doang ya? Oh, oke.
More to add. Let's go ahead and run a plan and make sure that everything looks good. All right, one to add, which makes sense. Looks like we've got a lot of attributes there for that EC2 instance. So let's go ahead and do that. Terraform apply, auto approve. Main, just like the AWS instance docs here. You keep that in mind. So tags equals TC main, just like so. All right, so now that's done. We've got our EC2 instance pretty much scaffolded out, obviously in gigabytes. And this is number here, since we're going to be specifying a number, not a string. In default, we will just say 8. And this is in gigabytes. So if you head to the AWS instance docs here, I've actually already scrolled down for you. You can see volume size of the volume in gigabytes. So just keep that in mind. And then we'll head back over to our compute.tf and let's add some tags. So tags equals name equals ntc main, just like so. All right, so now that's done. We've got our EC2 instance pretty much scaffolded out. Obviously, we have some more to add. Let's go ahead and run a plan and make sure that everything looks good. All right, one to add, which makes sense. Looks like we've got a lot of attributes.
Oh yeah, terraform state show our udah jadi dong. Tadi gua tadi. California, North California. Amat banget sih IndiHome. Banget woi. Ya Allah. Oh, instances sudah ada dong. Deploy my main instance. Ada biji tapi.
Use the there for that EC2 instance. So let's go ahead and do that. Terraform apply, auto approve.
Oh iya, di baru satu ya benar di subnet.
Alright, apply complete. Let's take a look in our dashboard here. And I'm in the right region.
Yeah,
MTC main is running and initializing. Perfect. So that's all for this lesson. Go ahead and mark it complete. And once again, if this is your
Ini salah di apa berarti? Tipu kali ya. Lambat banget sih. Kunci. Anjir, panggil banget.
Hello and welcome back. In this lesson, you're going to put your knowledge to the test once again and Terraform apply yourself. Go ahead and convert this EC2 instance resource to be a counted resource. You're going to want to give this resource a unique name, and that's a name tag, of course. So you'll want to ensure you create some sort of hint random resource in order to do so. And I'm going to add one major hint to this. You may want to check out your networking resources for tips on how you might handle this. So first of all, just to get you started, I'm going to head into variables, and let's just create a variable. Main instance count, just like so, type equals number, and default equals 1. So that should get you started. Of course, this 1 should be able to be scaled up and down, however.
Nungguin ya. Ini kasih tanda. Ush. Ini networking ya. Oops. Random resource gimana tadi ya, lupa ya. Random ID. Random get.
fit, but just note that right now the way we're doing things, it's going to be limited by the number of subnets you have. So you want to make sure that your subnet ID is also counted with the instance, and each instance goes to a different subnet. So if you have 2 subnets, you want to make sure that each instance goes into a different subnet. So go ahead, pause this video.
Sure.
And come on back. Alright, I created a random ID resource just as we did before in the networking section. I kept the byte length at 2, which is fine. If you did something different, feel free to keep it that way, or just step it on back to 2 to keep it simple. And the count. As you can see, I specified var.main instance count to the random ID to make sure that we get the right number of random IDs. Now under that, we have specified the count once again to main instance. Count, instance type, still there, AMI still the same, VPC security group ID is the same, but subnet ID, as you can see, we've added a count.index here to ensure that we are alternating subnet IDs for these AWS instances. Block device can remain the same, and then for the tags, I have added the random ID.mtc node ID count.index.dbc. So that's everything we should have needed to do this. Hopefully everything went well. I'm going to run a terraform plan, make sure everything works out. Alright, one to add, that is the random ID. We did not have to run a terraform init again because random ID is already initialized in our deployment. And as you can see, we have one to change, and that one to change is going to be our EC2 instance since we have changed the tags. Right here, we just need to change the tag, which is great because that just means the instance will be updated in place and does not need to be destroyed and reapplied. Alright, so let's run our terraform apply, auto approve, just like so. Alright, fantastic, all greens. Let's go over here to our instances. As you can see, this was our old name. Refresh the page, and now we have mtc main 54685. Perfect, everything went perfectly well. Once again, please make sure that if this is the last session of the day, you do destroy, so that you don't incur any extra costs if you're letting this run for a while. Otherwise, go ahead and mark this lesson complete.
Client timeout. Bener quote ini internetnya anjrit. Oke, berhasil. Bisa diganti. Loh, kok ada. Oke, satu random namanya. Oh, tapi cuma disatuin dong ya.
Come on back to the next one and let's continue the course. Hello and welcome back. In this lesson, we're going to add the SSH. Hello and welcome back. In this lesson, we're going to add the SSH key to our EC2 instance to ensure we're able to connect to it when needed. What we'll do first.
Bentar, tapi tidak memungkinkan ya, anjir. Nah, iya, tidak memungkinkan ini. Oke, karena internet tidak memungkinkan dan saya perlu belajar yang lain juga, kita tunda lagi.